Understanding average rate of change. Learning goals. Using a graph and intervals to find average rate of change. Finding average rate of change with no graph. And understanding real-world applications of average rate of change. What is it? Average rate of change is a measure of how much a function changes per unit over an interval. This is found through the slope of a straight line connecting the interval endpoints on the function's graph. Using the graph f of x equals x squared minus 9 from x0 to 3, we are trying to find average rate of change. Well, what do we need? We need identifying points. Our first point, 0 and negative 9, and our second point, 3, 0. We need our secant line, and now we need to solve. The average rate of change equation, f of x2 minus f of x1 over x2 minus x1. With the added intervals from the graph, we get f3 minus f0 over 3 minus 0. Further evaluated, it is 0 minus negative 9 over 3, which gives us an average rate of change of 3. Breakdown. First, we evaluate x1 equals f of 0. Using the graph, we can see that when x equals to 0 on the x-axis, we can see that on the slope we have a corresponding value of negative 9. x2 equals f3. Using the same process as before, we can find our corresponding y value, which would be 0. We can now insert these values into the equation and solve for ARoC. f of 3, which gives us 3. How about without a graph? Great question. To solve for average rate of change without the visual help of a graph, it's still quite easy. All we need is the equation of a function and our intervals. Let's make one up. f of x equals 3x squared plus 4x minus 12 for intervals 3 and 7. When solving average rate of change without a graph, instead we use intervals in the equation of the function to solve for f of x1 and f of x2 values. Here's how. The average rate of change equation with our intervals inputted. For x3, aka f of x1 or 3, we replace the values in the function equation with 3. This would make f of 3 27. Same goes for f7. We replace the x's in the function equation with 7, which would give our f7 a value of 163. Further evaluated, we get 163 minus 27, and we divide it by 4, which gives us an average rate of change of 34. Real-world applications. Average rate of change can be used in many different aspects of real life, ranging from finding the average rate of change in a population from specific points in time to the average rate of change for the speed of a vehicle during a drive. Review. Solving average rate of change with only a graph and given intervals, we use the graph and corresponding x and y values to find our f of x1 and f of x2 values. We take those points, f of x1 and f of x2, and we put them into the average rate of change equation, and then we evaluate. With only equation of points, we use the intervals for the average rate of change equation, use the function equation to solve for f of x1 and f of x2, and with the values of f of x1 and f of x2 solved for, we put these new numbers back into the average rate of change equation and evaluate. I hope this helps. Thanks for watching.